Hey everybody, this week we're going to be looking at surface area. So first we're going to start with prisms and cylinders, and then our next lesson we'll look at pyramids and cubes. Okay, so remember these are our prisms. Okay, prism has two bases that are congruent and parallel, right? And then the distance between them is the height of our prism. Okay, so no matter what base it's sitting on, whatever it's on, that is not the base of this prism. Remember, this is a triangular prism because it has two triangles that are parallel and congruent to each other. So this is going to be the base. Okay, we're going to find the area of this. We're also going to find the perimeter of it. Those are the two things we need. We need the perimeter of this triangle, we need the area of this triangle, and then we need its height. Okay, the height of the prism, not the height of the triangle, the height of the prism is how far between this triangle and this triangle over here. So if it was sitting on the triangle, then the height is standing straight up and down. But if it was sitting on its side, then the height of our prism is going to end up being a diagonal or a horizontal line, how far between those two bases. Okay, so what I want you to keep in mind is, if you can imagine, this is the base right here, and the height goes away from it at a right angle. See how that makes a right angle to each other? Okay, so we're going to find the base, and then the line going away from that is going to be the height of our prism. Okay, same with our rectangular prism. The nice thing about a rectangular prism is we can pick any one of these rectangles to be the bases. Okay, so if I pick these to be the bases, then this little line right here between them, that's going to be the height of my prism. If I pick these to be the bases, the little tiny bases, little squares, then this line right here, how far between them, becomes the height of our prism. Okay, so you kind of want to imagine taking your prism and standing it on one of those bases, then your height is going to be going up from there. Okay, and the last one is our cylinder. Okay, so the nice thing about our cylinder formula is the only variables we have are going to be the radius and the height. So we need the radius, remember, which is from the center of our circle to the edge. So the only way they can make that harder is if they give us the diagonal all the way across. Then we're going to chop that piece in half to find the radius. And then the height, again, of our cylinder is how far between these two circles. Okay, so from one circle to the other, that's going to give us the height. Sometimes it'll come along the edge here. Sometimes it'll go right down the middle, kind of like an axis or an axle, like right in the middle of our tires, right, on our car. So cylinders, we only need the radius and the height. Sometimes the cylinder will be sitting on its side, and the height is going to go side to side, which is kind of weird, but not really, doesn't make it any harder for us. Okay. So our formulas, if you have not yet gotten them written down, because I keep putting my hands in front of them so you can't write them down, these are our formulas for area of a prism. We have LA, which stands for lateral area. The lateral area of a shape is the part that is through the middle, not including the bases. So if you think of like a soda can, like where you would put your hand or where you would put the label, that's going to be the lateral area. Okay, on a prism, the lateral area just doesn't include our bases. So if these are our two triangular bases, the lateral area is just going to be these three rectangles here. So how much space is all of that? Okay, when I find the total surface area, I'm going to add on these bases. Okay, and remember, surface area is like you're covering a present with wrapping paper, right? How much paper is going to cover that entire surface? Or if you wanted to paint the walls of your house or your room, okay, when you paint all of the walls, that would be your lateral area, like around the middle. And then if you want to paint the ceiling or the floor, which would be kind of awkward, but you could do it, that would be your total surface area. So usually when we're painting rooms, we only paint the walls, which is going to be that lateral area. Okay, S then stands for surface area, which is the whole thing. So lateral is around the middle. P, capital P for perimeter of the base. H for the height of our prism. Surface area is the whole thing. We're going to take that same pH that we just found. We're going to add on the two capital B. Capital B stands for area of the base. Okay, so 2 areas of the base. And then we'll get into our cylinder formula. Okay, all right, so I got a couple pictures already drawn here. So we'll start with number 1. Surface area of a prism and a cylinder. Okay, so step 1 is to name this shape. Okay, if you were to look at this shape from what we learned last week, what kind of shape would you call this? Focus this a little bit. You would call this, thank you, you would call this a rectangular prism. Okay, so this word right here is going to be our base. Whatever name we give for the prism, that tells us what the base is. Okay, so the base is going to be a rectangle. All right, so we're going to pick a rectangle from this picture, and there are a whole bunch that I can pick from. So let's use, well, let's go ahead and use this one that's down here on the bottom. Okay, so I'm going to shade in this piece as the base. Okay, and I'm going to come right over here and I'm going to draw that base just because this is a little bit easier. I'm not going to draw it as big as I have here. Okay, this is my rectangular base. It has a side of 9 and a side of 13. Right? Okay, so I'm going to write down my formulas. Let me grab them here from this other page. All right, so here are my formulas for prism. I'm going to do lateral area, which is capital P times H, if you want to put a little dot in there for times. And then I'm going to leave a couple lines because I'm going to fill in my numbers and put my answer there. And then I'm going to do SA for the total surface area, which is PH plus 2B. So P times H plus 2 times B. Okay, so here's what I like to do. I like to get all of the work out of the way up front, and then I can just plug into my formulas and type into my calculator, and I'm going to have my answer. Okay, so with that being said, I need a number for capital P. Capital P stands for perimeter of this shape that we just drew right here. So to find the perimeter, we add all sides. 9 plus 13 plus, how long is this piece right here? 9, yeah, because it's the same as what's over there. And then this piece right here is another 13. So to find the perimeter, 9 plus 13 plus 9 plus 13. So what does that make? You tell me while I grab my calculator. 9 plus 13 plus 9 plus 13 makes 44. So capital P is going to be 44. Then we have the H. H stands for the height of our prism. Height of the prism. Now here's the thing. Do you see how I've already used the 9 and the 13 as part of my base? That neither of those numbers can be the height. The height has to be going away from that surface to the other part that's parallel to it. Do you see how the parallel pieces appear on the top? Like this is kind of the bottom of our shape to the top. So how far between the bottom and the top of this shape? This 7 is the line that's going away from it, away from the base that we have marked. So this 7 is going to be our height. H is 7. And then the only other thing we need is, let's see, capital P, H already did that, 2 doesn't change. We need a capital B. Capital B stands for, don't say base because that's not right, area of the base. So the area of the rectangle, which is the base, how do we find the area of a rectangle? Yeah, length times width or base times height. I guess base times height is better. That's what we did, base times height. So the base and the height of this rectangle. Now, I'm not using this height. This is the height of the prism. I'm not going to use that. I just want the height and the base of the rectangle. So that's going to be 9 times 13, the two sides of that rectangle. 9 times 13 makes 117. Okay, so here's the nice thing now. Now that I have these 3 values, this just becomes substitution. So we're going to go up here to our formula for lateral area of a rectangular prism, and capital P is going to be replaced with a 44. and there's a times sign after it. H is the height of our prism. We're going to replace that with a 7. So I'm going to pick up my calculator and do 44, oops, just kidding, 44 times 7, and we get a lateral area of 308, and these are feet squared. Area is always squared. So that's the lateral area. That would be like around the middle here, not the shaded part, around the middle, like the walls. Okay, if the shaded part was the floor, right, around the middle. Okay, so now to find the surface area, we're going to take pH, which we just did, right? This 308 is capital P times H, so I'm just put that 308 right there. If you want to go ahead and write 44 times 7, it's going to give you the same answer. It does not really matter to me. Plus 2 times, do we know what capital B is? Capital B is 117. Okay, so here's the deal. Remember PEMDAS order of operations? We always multiply before we add. So we're going to do 308 plus whatever 2 times 117 is. So 2 times 117 is 234. 308 plus 234 makes a surface area of 542 feet squared. Okay? All right, let's try a triangular prism. Triangular prism. Okay, so the name of this shape I just said, okay, is a triangular prism. Now notice that it is sitting on a rectangle. Now just because it's sitting on a rectangle, if you say that's the base, that would make this a rectangular prism. Does this look like a shoebox? Or a cereal box? Those are rectangular prisms. This is not a rectangular prism. This has a triangular base. It just happens to be on the side, okay, or on this other side over here, right? Those are my two bases. So this makes this a triangular prism. Okay? So I'm going to go ahead and mark the height of this prism. Now the height of the prism is how far between the two bases. So do you see this line right here that connects those two triangles? This is the height of our shape. We're not going to use that 16 for anything else in the whole thing. That's the height of our prism. We'll deal with that later when we go to plug into our formulas. Okay, so let's go ahead and draw the base right here. What shape do we say the base was? A triangle. So I'm going to draw that triangle that looks kind of like this. Pretend that's a nice triangle. All right, so the sides of this triangle, we've got a 9 down here at the bottom. We've got a 12 over here on the side. And do you see how this hypotenuse, see there, there's no number there? Do you see that value somewhere else in our picture? Do you see it right here? Do you see how that's the same? This line right here is the same as this. So that's going to be a side of 15. Now, if it wasn't there, I could use Pythagorean theorem to solve for the missing side, because this is a right triangle. They show us the right angle there. So I could square 9 and 12 and add them to get this longer side, right? Square and add. All right, so for our formulas, lateral area is capital P times H, and surface area is capital P times H plus 2 times capital B. So again, I'm just going to solve for each of these letters, then plug my numbers in. Okay, so I'm going to come over here. What does capital P stand for? P stands for perimeter of the base. So this thing right here, I'm not talking about the prism right now, I'm just talking about this base, this triangle. So if I add these sides together, we're going to have 9 plus 12 plus 15. 9 plus 12 plus 15 makes 36. So that's capital P, 36. What did we say H was? The height of our prism. We already said that was 16. And now the only other thing we need is capital B. What does capital B stand for? Not base. Don't say base. It stands for area of the base. So what shape is this base? It's a triangle, exactly. So what is our formula for area of a triangle? Base times height divided by 2, or half, I guess I'll write it that way, half base height, right? Half base height. Half. So which of these numbers are the base and height of this triangle? Now I'm not using this 16. That's the height of my prism. I don't care about that right now. I just care about this triangle. So which sides are we going to use for this triangle? How do I know? What do I look for? This right angle. The two sides that touch this right angle are going to be the base and the height of our triangle. So we're going to use the 9 and the 12, and it doesn't really matter which one goes where. So we're going to do half of 9 times 12. So half of 9 times 12 is 54. So capital B is 54. Now we've done all the hard work, so now it's just plug these numbers in for our variables to find our final answers. So LA is, I'll just use black, whatever we go. Okay. Capital P stands for the perimeter of our base. We said that was 36 times the height, which is 16. 36 times 16 is 576. So our lateral area around the middle here, not including the triangles, around the middle of this prism is going to be 576 inches squared, or square inches. And then to find the total surface area, I'm going to add on these two triangles that are on the end. So I'm going to take that 576 that we just found for pH. That's what we already found. We're going to add on 2 times, how big were the triangles? 54. So 2 54s makes 108. 576 plus 108 makes 686 inches squared, or square inches. Okay, so again, I really think the easiest way to do this is to name the prism. What kind of prism is it? Draw whatever shape that base is. Whatever you use to name it, that's the base. Solve for perimeter, area, figure out the height, what's the number you didn't use yet in the picture, and then plug, 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 and you're good to go. Okay, now there are other types of prisms. We are only going to look at these two here for today. There are trapezoidal prisms and pentagonal prisms and hexagonal prisms and all that other kind of stuff. I'm not really going to worry about that right now. Okay, so we're going to mainly focus on the rectangular and the triangular. Okay. All right, so let's switch over to our cylinders. Okay, we're going to do 2 cylinder problems real quick here. So on a cylinder, okay, even though a cylinder is like a prism, we are not going to use those same formulas. This has their own formulas. Oops, I don't know why I put S. LA is lateral area, and we said the lateral area of a cylinder is 2 pi RH. 2 pi RH. And then for our total surface area, we're going to take that same thing, 2 pi RH, what we just found, plus 2 pi r squared. Okay, so the nice thing about this is actually the same formula. Okay, 2 pi r is the circumference of a circle, which is the same as its perimeter. So this is still perimeter times height. It's just round now, so we use the formula for perimeter or circumference of a circle. Okay, so this is still pH, and then this is 2 times pi r squared is the formula for area of a circle, which is our capital B, area of the base, area of the circle for this problem. Okay, so same formulas, they've just replaced our values with those for a circle, okay, because they won't ever change. All right, so in this formula, or in these formulas, I see two letters. I see an R and I see an H. And if I know those two values, then I can just plug and chug. Okay, so R stands for radius. Where is the radius of our circle? From the center to the edge. So this 11 is going to be our radius. And the height of our cylinder is how far between the two circles. So this is going to be our height. And again, sometimes it's going to go right down the middle. Sometimes it will go along the edge. So the height is 26. Okay, so we're just going to come over here and we're going to plug those numbers in. So our lateral area around the middle here, like where our label would be or where your hand would go if you were holding this as like a soda can. Okay, 2, pi doesn't change, R is 11, H is 26. Okay, so in between all of these, we're going to have a times sign. 2 times pi times 11 times 26. I don't have, when you turn to the side, you're going to get your pi value. 2 times pi times 11 times 26. 2 pi 11 26. Okay, so we're going to round this to the, let's do 2 decimal places. So we'll look at the second 9 here. After that 9 is a 0, so we'll leave that there. So 1796.99. What are these, yards? Yards squared or square yards. Okay. 2 pi RH. We just found that. 2 pi RH. So I'm going to bring down the 1796.99, and then we're going to add on 2 times pi times R, which was 11, and then it has a square on that 11. Okay, so here's the nice thing about using my calculator is this is my answer right here. So I'm just going to keep going from there. Plus 2 times pi times 11 squared up to the second power gives me 2,557.2, and then there's a 5. After the 5 is a 6, so I'm going to bump that up to 26. Okay, yards squared. That's our surface area. Okay, if you want to do this part by itself, 2 times pi times, oops, that's not times, 2 times pi times 11 squared, it would give you 760.27, and then you could add that on to whatever that number is, and you get the same thing. Okay. So cylinder is very little work. Find your radius, find your height, plug, 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 type in your calculator. Let your calculator do the work. Okay, last one. Let's see, this cylinder is sitting on its side. The base is still the circle, which makes the height of our prism how much? Please don't say 15. This is not the height of our prism. This is how big the circle is, right? The height, or sorry, the cylinder. The height of our cylinder is this 9 right here. This line between the two circles, that's our height. And then this 15 is that the radius? No, that's not the radius, that's the diameter, right? The diameter is 15, but our formulas don't call for the diameter. So what am I going to do to that diameter to get the radius? Chop it in half. So the radius is going to be 7.5. So radius of 7.5, height of 9. Okay? Formulas are really, really important. Y'all want to do really good work? Write the formula down. Make sure you have the right formula for the right shape, cylinder, lateral area. Then we're going to plug our values in. 2 doesn't change. Pi doesn't change. R is changing to 7.5 times the height of our cylinder, which is 9. Okay. 2 times pi times 7.5 times 9 is 424. Not 11, the 5 after that, so it's going to become 0.12. Lateral area, meters squared. Okay. And then our total surface area, we're going to take that same formula, 2 pi RH, and we're going to add on 2 pi r squared. So this, what we just found, is the 2 pi RH, so that's 424.12, and then we're going to add on 2 pi, what do we say r was? 7.5 squared. So 424.12, we're going to add on 2 times pi times 7.5 squared, and we get 777.54. 777.54 surface area. Okay, so here's what I will tell you. The thing that people make mistakes on, especially in this formula, which seems like, I mean, this is just plugging numbers into a formula, right? We don't really have very much work that we have to do for this, okay? The problem is people don't write the formula down properly from their formula chart. So it's really important that you have the formulas and that you write them correctly each time. Don't think you just have it memorized, but really follow that, okay? And then the other thing on our prism is that the base is not always on the bottom of the shape. The base is whatever we use to name it. And then from there, we're going to find the perimeter and area of that base. And the height is how far between those two bases. It's not always the piece that is pointing up to the sky. It's not always vertical. Okay? All right, so that's surface area of prisms and cylinders. Next time, we're going to look at the cone and the pyramid, and maybe a little bit of the sphere if we have time for that. This week we'll focus on surface area, next week we'll focus on volume, and then we'll be done. Okay? All right. Love you, bye.